feel like this chapter starts out with a lot of quick problems, but they use a bunch of different rules. And then it gets into some pretty complicated stuff by the end, right? So it's an interesting mix. Use the product rule to multiply. So we just need to multiply what's inside the radical. So what is the square root of 7 times the square root of 6x?
It'll just be 42x.
But don't forget what?
Squared. It was square root.
Square root of 42x. Good. And then number 20 is kind of similar to what we've already done, right? Where we've talked about where you have to take the square root of the top and the square root of the bottom. The only difference here is we cannot simplify the square root of 3 because it doesn't work out cleanly, but we can simplify the square root of 25. What does that give us?
5.
5. So the answer here would be square root of 3 over 5. Be careful when you type this into my math lab that only the 3 is under the radical. So there is a difference between inputting that answer and inputting this answer, right? So you have to be careful when you type it in that you're not putting the whole thing under the radical. Okay, now we're going to add and subtract some radicals. When you're adding and subtracting, what is really important?
What's inside the square root?
Has to be what?
It has to be the same.
Has to be the same. So the first thing we need to do here is simplify both radicals to see if we end up with the same value inside each radical. So what can you simplify if you look at the first radical? What's the only thing that can be simplified?
The x.
So how does that become simplified?
It would be a 2x.
Inside the radical, it becomes 2. The 2 stays, and 1x remains, and then what else happens?
On the outside is a 2x. Or wait, 5x. 5x, my bad.
So a few ways to think about that. One is you are taking the 3, the exponent, and dividing it by 2, like we did before. And that gives you 1 with a remainder of 1, which tells you that an x goes on the outside and also an x stays on the inside. So that's one way to do it, is that you're kind of doing like good old-fashioned division and seeing like, okay, this 1 is the exponent on the outside, the remainder is the exponent on the inside. Okay, that's one way to do it. Or you can even do the trick I mentioned earlier, that x cubed is really 3 x's, right? So there's a pair of x, so that tells you an x goes on the outside and this x stays on the inside. There's other ways you could think about it, but those are at least 2. Okay, how about the second radical? How could we simplify it?
You can pull a 2 out.
Yes, so the 8, several different ways. You can either think of the 8 as 4 times 2, right? And therefore the square root of 4 is 2, right? So you can think of it as like 9x square root of 4 square root of 2x, kind of separate it like that because 4 times 2x is 8x, but then the square root of 4 is 2. I'm with you. And then you have to multiply that by 9x. So what does that actually give us on the outside?
So you have an 18x and then the square root of 2x.
Good. So now I'm bleeding into the next problem, but that's okay. We'll adjust that in a second. Now you have 5x square root of 2x plus 18x square root of 2x. So now all of your radicals are the same, right? Both terms have an x square root of 2x. So you can actually add the coefficients. So what is 5 plus 18?
23.
So your final answer here is 23x times the square root of 2x. How would you simplify the square root of 27?
So you can pull a 3 out of that.
So you could split it up into 9 times 3, and then you're looking for perfect squares that go into it, right? So the square root of 9 is 3. So that whole term becomes 12 times the square root of 3. Good. How about the square root of 18? What could you pull out of that?
3.
Okay, and then 75.
A 5.
Good. 75 is 25 times 3. So I agree with you that you get a 5. Okay, so now you have 12 square roots of 3 minus 6 square roots of 2 plus 5 square roots of 3. Is that our final answer?
Nope.
No, because we need to combine like terms. So which terms can be combined here?
You can add the 12 to the square root of 3 to the 5 of the square root to 3.
And what does that give us?
Yeah, it's 17 to the square root of 3.
Minus 6 square roots of 2 just gets brought down, but it can't be combined because the one term has the square root of 3 and the other term has the square root of 2. Okay, what about number 23? There's actually a lot that can be simplified there. So what is the square root of 9? So what is the square root of 9?
3.
3, good. And then what is the square root of b cubed?
Wouldn't it be a b on the outside of the radical and then a b on the inside?
Exactly. Okay, what about the next term? Do you want to keep going, Alyssa?
Sure. It would be 5b and then radical b.
Good, and then the last term.
And then negative 9b radical b.
Good. And then what would you do from there?
Would you just combine all of them?
Mm-hmm. So 3 plus 5 is?
8.
Mm-hmm. Minus 9.
Negative 1.
Mm-hmm. So you could either write it like that, negative 1, b square root of b. They would accept that, or if you didn't have the 1 there, that would also be fine. Negative b square root of b. What about number 24? How could we simplify the square root of 54x? Do you want to try this one? What goes into 54? What perfect square goes into 54? But you can use it to help you figure out what divides evenly. So do you know your perfect squares? Like 1 squared is what?
2 or 1
1. Okay. 2 squared or 2 times 2?
is 4
Good. 3 squared?
is 9
4 squared?
16
5 squared?
is 25
Good. 6 squared?
is 36
7 squared?
is 42.
49.
Okay, 49.
8 squared?
64.
Good. We'll stop there. There's more, obviously, but we'll stop there. You're looking for what number that when you divide it, you get an answer, right? That you don't get a decimal, but you get a whole number as your answer. So you can, if you want, use your calculator and go, okay, if I do 54, you know, obviously you can't divide by a number bigger than it, right? So 54 divided by 49, okay, that's going to give me a decimal. 54 divided by 36, that's a decimal. 54 by 25, that's a decimal. And you want to find the biggest perfect square that divides evenly into 54. So do you know if any of these numbers divide evenly into 54?
So you can do, well, 9
Very good.
and 6.
Exactly. Very good. So you can split up 54 as the square root of 9 and the square root of 6x because the x doesn't simplify, right?
Right.
All over 4. Good. And then I'll go ahead and finish that part and then we'll deal with the other fraction. What is the square root of 9?
3.
3. Good. So the whole first fraction becomes 3 times the square root of 6x all over 4. Now let's look at the second fraction. Remember we talked earlier that when you're doing the square root of a fraction, you can do the square root of the numerator divided by the square root of the denominator. So we're going to leave the square root of 6x alone, but then what is the square root of 4?
2.
2. Very good. So in order to add these fractions together, what do we need to do next?
So we need to multiply the 2.
Mhm. And that multiplies on the outside. What I mean by that is the first fraction is going to stay the same, but the second fraction is going to become 2 times the square root of x, because it's not the square root of 2. If it was, we were multiplying by the square root of 2, then you would actually multiply it with the 6x inside the radical, right? But this is like a separate world, I like to say. The 2 is outside the radical, so it can't just magically jump into the radical. So it stays outside. 2 times 2 in the denominator is 4. Now that we have a common denominator, we can add the numerator together, right? So the 4 stays in our denominator. And what does the numerator become?
So it'd be 5
Very good.
and then radical 6x.
See, you got it. Okay, so now we're going to find the domain of some radical functions. And what is the key thing we talked about? That when you take a square root, what can you not take a square root of? And get a real answer. It might give you an imaginary answer, right? But what can you not take the square root of if you're trying to get a real answer?
Is it a negative?
A negative, right? So that's why when you're trying to find the domain, which is the same as saying what x values am I allowed to plug into this function in order to get a real number as my answer, we say that the whatever's underneath the radical has to be greater than or equal to 0, right? It has to be positive or 0. It's not allowed to be negative, because we know if you take the square root of a negative number, you get an imaginary answer, and we're trying to get real answers. So how do you solve that for x? How do you get the x by itself on one side of the inequality?
Don't you just add the 9 to the other side so that way x is by itself?
Yes, very good. So we add 9 to both sides. So what does that give us?
X is greater than or equal to 9.
Good. Then they want the final answer in interval notation, right? If it helps you to figure it out, you're not required to graph it, but if it helps you, you can think of this like we have a number line. We're starting at 9, and you guys use brackets and parentheses on your number lines, right? So it would be a bracket, right? This is the course that uses the brackets and parentheses, I think.
Yes.
Yeah, okay. I always have to check that with you guys because the other course doesn't. Okay, so if it helps you, you can graph it first to see that, okay, we're starting at 9 and then we're going forever positive, forever to the right towards positive infinity, because once you graph it, it kind of has all the pieces there, right? Then you have a bracket with the 9, because you always have to read from left to right, going up to infinity. And with infinity or negative infinity, you always use parentheses because you cannot equal infinity, which is what the bracket would mean, that you can equal it. So how would you do number 26? And feel free, Allison, Caitlin, Vivian, I just realized you all were here. Feel free to jump in.
You would set it up the same as you did for number 25. You'd put x minus 6 is greater than or less than, or greater than or equal to 0.
Good. And then how would you solve it, Caitlin?
Add 6 on both sides.
Good.
And then create the number line to find the interval notation.
Okay, good. We can do that. So what would you put on the number line?
You would put 6 in the middle.
Mm-hmm.
And then you would use the bracket because it's included.
Mm-hmm.
And then you would go to the right because x is greater than 6.
Very good. So then how would you write it in interval notation?
You would have the bracket, 6, and then infinity with the parenthesis.
Excellent. Thank you.
You're welcome.
So let's check out number 27. What would probably be a good first step in number 27?
Finding the square root of 4, which is, well, square rooting 4, which is 2.
Very good. So that becomes 5 times 2, right? Minus 2 plus the square root of 2. What is 5 times 2?
10.
10. Good. And then we have 10 minus 2 plus the square root of 2. So what does that give us?
8 plus radical 2.
Exactly. Can that combine?
No.
No, because they're not like terms, right? The one is just a whole number, the other's a radical, so they cannot be combined. Very good. So that would be the final answer there.